Although your service manuals and TSBs provide about all the service information you'll ever need, I know that you, like me, appreciate a demonstration, particularly when you're performing a new procedure for the first time. That's what we're about to do in this Powertrain update. The purpose of this video and the materials that come with it is to keep you informed of upgrades to Ford Powertrain products and to demonstrate procedures that'll help you do the job right the first time. Put these quick reference booklets in your toolbox where they're handy when you want to look something up. Refer to the program book for a quick review of what's covered in the video. The topics we'll be dealing with include the engine, automatic transmission, and drive axle. That's right, a technical video that covers the powertrain. After all, a lot of technicians work on the whole vehicle. Even those who specialize on, say, automatic transmissions tell us they want more powertrain information. While some of the information we'll cover has been published in TSBs and on Oasis, we believe the topics deserve additional attention. Other topics deal with running production changes which are so new they're not in your service manuals yet. Part 1 shows a preferred way to remove gasket material to prevent internal engine contamination and cut down on future repairs. It also introduces a new environmentally safe solvent that's recommended for cleaning surfaces that are sealed with room temperature vulcanizing or RTV compounds. Part 2 covers drivability and electrical topics. Using a digital volt-ohm meter, we'll check electrical connectors and wiring and diagnose a no crank and a no start concern. We'll also demonstrate the recommended tools, supplies, and procedures for making electrical repairs. Other concerns we'll cover include a persistent engine stall after a cold start, hesitation or stumble on initial acceleration after a cold start, and a surge at cruise that's mistakenly blamed on the heated oxygen sensor. We'll also demonstrate a new harness assembly that's used with a DVOM to determine the opening point of thermostats. Part 3 deals with engine and transmission leakage concerns. Few concerns are more annoying to your customers than these. In Part 4, we'll discuss Ford's exchange program for engines and automatic transmissions. The exchange program's a good way to go when you have to remove a transmission or engine from a vehicle for a major repair. In Part 5, we'll move to automatic transmissions and transaxles and present information about recent upgrades to 3 models, the E40D, A4LD, and the AXODE. Before we leave transmissions, we'll review important diagnostic procedures. To cap off the video, we'll discuss an upgrade to the rear wheel bearing seal on the F-250 and 350 light trucks. You may be aware that there's been a concern with leakage at this seal. The new seal kit should put that concern to rest. We'll finish our visit to the rear axle with a discussion of lube level checking and filling procedures. There's more to this than most people realize. An engine that's properly cleaned when it's serviced is less likely to require a future or repeat repair than an engine that's improperly or carelessly cleaned. This is especially true when the repair involves the replacement of valve cover, intake manifold, or cylinder head gaskets. When gasket materials removed with power tools like hand grinders, sanders, or rotary wire brushes, there's always a chance the sealing surface will be scratched and that some of the abrasive material will get inside the engine where it may scuff pistons and bores and chew up crank and cam bearings. Damage like this can lead to a loss of oil pressure, high oil consumption, engine noise, and eventual failure. And it can be prevented. When you're getting ready to clean a gasketed sealing surface, put your power tools away. They have no place here. To correctly prepare the surface, follow this process instead. First, always place clean shop towels over exposed engine cavities to prevent contaminants from entering the engine. Next, identify the type of material before you start to clean. If the part is iron or steel, Clean away old gasket material using a sharp, high carbon content steel blade. The material will peel away easily. To aid in removing loosened debris, some pros use a portable shop vac as they scrape. These pros also tell us they use the time they spend cleaning to review the root cause of the concern, turning what many consider to be a menial task into time that's well spent and pays big dividends. To prevent nicking or gouging the surface, hold the blade flat and apply a slow, steady pressure. You might also grind the corners of the scraper round to reduce the possibility of surface damage. Surface imperfections can channel fluids where we don't want them. If the part is made of a soft material like aluminum or plastic, use a correspondingly soft scraper in combination with a Ford-approved cleaning agent. This one's Teflon. Avoid using steel scrapers that may cut, gouge, or burr soft surfaces. Give the solvent time to do its job. Then apply a steady pressure and keep the blade flat to the surface. When a surface is clean, remove the shop towel slowly and carefully to avoid dumping the scrapings in the engine. And remember, to get the most productive use from the time you spend cleaning, use it to review your root diagnosis of the concern. Here are a few tips worth noting to make sure your newly cleaned surfaces stay sealed. Because engine designs and sealing materials have evolved over time, consult your service manual before starting assembly. Ford original equipment parts are generally required when performing warranty repairs. Although aftermarket products may look okay, you can't be sure they're manufactured to Ford standards. Don't assume a gasket has to have sealant. It may not. Gaskets with precast silicone beads will tend to shim and leak if sealant is applied to the mating surfaces. Keep dirt, lint, and unwanted chemicals off components and new gaskets you're installing. Avoid the use of gasket positioning aids. They may leave residues in the engine that are incompatible with oil or may end up in the catalytic converter, causing emissions system damage. Silicone-based RTV can impair the operation of the heated oxygen sensor if it gets hot enough to burn in the combustion chamber. Tighten and torque fasteners exactly as recommended in your service manuals. Torque sequences on components like the intake manifold and cylinder heads are critical. Proper sequencing makes for a better seal and protects the part from distortion and warping. In some instances, you may have to detorque fasteners used on aluminum components. When you're finished, verify the repair. If you used a black light and fluorescent dye to locate the leak, clean the area thoroughly of any dye residue and black light it again after operating the engine for 15 minutes. A moment ago, I said to use a Ford-approved cleaning agent to remove material from soft surfaces. Here's one of the newest. Its active ingredient comes from citrus peels and has the chemical name delaminine. The beauty of delaminine-based solvents is that they do a better cleaning job than substances like brake clean. And unlike conventional brake clean, delaminine is environmentally safe. An ideal use for this solvent is preparing sealing surfaces to receive an application of silicone-based RTV formed in-place gasket material. To prepare the surface, carefully clean away as much of the old sealant or gasket material as possible, following the procedure we just outlined. Then, clean away all remaining traces of old sealant, dirt, and grease with a solvent that meets or exceeds Ford specification WSE M5B392A. Such a solvent will typically contain greater than 95% delaminine as the active ingredient. It's a good idea to wear protective gloves to prevent the solvent from coming in contact with your skin. Avoid using brake clean or carburetor cleaner. They can leave a residue that interferes with RTV's ability to adhere. If the RTV won't cure properly, a leak may occur later on. After cleaning the surface, apply the RTV in the amount specified in the service manual. And remember, RTV starts to skim over in the presence of the humidity in the air, losing its stickiness in little more than 5 minutes. Unlike those old-style cleaners, any slight moisture left by delaminine will actually aid in the RTV curing process. You'll be able to obtain delaminine-based solvent through Ford Customer Service Division in the near future. Drivability and performance concerns are among the most challenging to diagnose, especially if they're intermittent or don't set diagnostic trouble codes. Taking the customer's description and systematically reducing it to a root cause requires system knowledge, information, and the right tools. The information you need can be found in your service manuals, TSBs, OASIS, and in a well-written repair order. The Customer Information Worksheet in Section 2A of the 1994 Powertrain Control Emissions Diagnosis, or PCED manual, is particularly useful because it helps the customer describe the concern in terms we understand. You might want to make copies of the worksheet and give them to your service writers to help them better define the customer's concern. Have them attach it to the repair order. The tools you'll need to tackle drivability and performance concerns include items like a good set of jumper wires, a digital volt-ohm meter, and the advanced electronic devices available from Ford. With these tools, your manuals, and your experience, you're well on your way to tackling the toughest concerns. Our first case is an intermittent no-start condition that we've seen in some 1991 to present Explorers equipped with the 4-liter engine. While this topic was addressed in TSB 93-1913, there's more you need to know. The TSB indicates that battery acid emissions may cause wires and cables at the battery to swell or discolor. The condition may be present in either the positive or the negative battery cable, or both. While enough current usually gets through to preserve the EEC system's Keep Alive random access memory and run the instrument panel startup display, the corroded cables can't deliver the current flow required by the starter motor. In the case we're describing, the root cause is the connection between the battery cable clamp and the cable wire installed in it. Electrical continuity is so poor it's like having no connection at all, or so it appears to the starter. If you see traces of powdery acid residue around the terminal, but the cable appears normal, it's still possible there's enough corrosion between the clamp and wire to cause a no-start condition. The wire need not be swollen. To determine if battery acid emissions have added unwanted resistance to the circuit after you've confirmed the battery is okay by a load test, set the DVOM to DC volts and perform a voltage drop test. It's a two-step process. First, check for a voltage drop between the battery's positive terminal and the cable clamp. If the connection's good, you'll see a reading of less than 0.3 of a volt. Next, check for a voltage drop between the battery's positive terminal and the starter solenoid's battery positive terminal. A voltage drop of more than 0.3 of a volt indicates there's excess resistance present and the cable should be replaced. Repeat the voltage drop tests on the other cable, probing to ground. It may be necessary to repeat all the checks under load. Although TSB 93-1913 enables us to take a shortcut around the diagnostic process that's described in the service literature, you'd come to the same conclusion by going by the book. You'd discover that the potential root causes of the no-start are an open fuse, a low battery, an open circuit, or a high resistance in the feed circuit to the starter solenoid, or an inoperative starter. So whether you follow the TSB or the manuals, you'd arrive at the same conclusion: a high resistance connection. There's another no-start concern we need to cover. This time it's with the 91 to present Town Car, the 92 to present Crown Victoria and Grand Marquis, and the 91 to present Ranger and Explorer. For these no-starts, the cause can be trickier to locate. What we've learned is that the female terminal of the wires that attach to the EEC relay and the fuel pump relay sometimes isn't tight enough to provide a good connection. To verify that this is the cause, use a helper or remote switch to crank the engine, and as it cranks, wiggle the EEC relay and fuel pump connectors. If the engine starts, you've located the cause. Although some people reshape the terminal to obtain a solid connection, the preferred repair is to measure back from the terminal end about 4 inches and cut the wire the terminal's connected to. Remove the terminal from the connector using a thin screwdriver or a pick, and install a new pigtail with attached terminal from the wire terminal repair kit that we'll look at in a few minutes. If the wiggle test we showed didn't indicate the source of the concern, it's time to go to the books. For this kind of an intermittent concern, you're most likely to locate the cause by using the EEC4 monitor and monitor recorder. Diagnosing the source of an electrical concern requires a systematic approach. The first requirement is to get acquainted with the circuit using the Electrical and Vacuum Troubleshooting Manual, or EVTM. When you look at a circuit schematic, you'll find it can be reduced to these basic parts: a power source, typically the battery or a branch circuit from the battery, wires that carry the current from the source to a load, overload protection devices like fuses, circuit breakers, or fusible links, control devices like switches and relays, a load that performs work like a lamp, a starter or fan motor, or a solenoid, and a ground circuit that completes the circuit by routing current back to the battery. The way in which electrical circuits are constructed dictates the diagnostic approach that's used on them. Basically, it's like simple arithmetic. Start with the whole circuit, then subtract parts that test good. You're left with the part that's at fault. When you suspect a fault exists in a circuit, you'll be dealing with just a handful of possibilities. The circuit may be open, there may be a short circuit, the load itself may be inoperative, or the ground circuit may be faulty. Probably the handiest tool you can use in circuit diagnosis is an auto-ranging multimeter like this digital volt-o-meter, or DVOM. It enables you to measure current, voltage, and resistance without having to think first about setting the range or getting the right polarity. If you're thinking about getting one, be sure it has an input impedance of 10 megohms to protect sensitive electronic devices from excessive current draw or excessive current delivered to the circuit by the meter. It's also a good idea to equip yourself with some jumper wires. Jumper wires can be used to provide continuity across components that you suspect are open, or to supply voltage to a circuit independent of normal switches or wiring. You can make your own jumper wires and customize them to a variety of applications by using different style terminal connectors. That way you stand a better chance of getting a good connection with the least amount of trouble. You should check your jumpers periodically for continuity. Set the DVOM to the ohm scale. Probe the ends of the jumper, and you should see readings below 5 ohms. The lower the better. This check makes sure any resistance in the jumper won't contribute to a measurement error when you check a circuit. Because you'll find lots of help in your manuals when it comes to using meters and other test devices, we'll turn our attention now to the inspection and repair of electrical connectors and wires. Before making a repair or swapping a part, make sure the connector's faulty. This is accomplished by narrowing your search to the component through circuit diagnosis. As you inspect a connector, look for these irregularities: a terminal that's been crimped onto an unstripped wire, a terminal that's crimped onto an improperly stripped wire, where wire strands have been cut off, connectors that aren't fully mated, deformed female terminals like the ones we talked about for the intermittent no-start concern, or terminals that are pushed back and not properly seated. When a continuity check indicates an open or short exists, you may be able to find the location by operating the device or system while you flex the wire to trigger a fault. A scan tool in wiggle test mode will detect the fault. To locate broken strands inside a harness, remove the harness tape and flex the conductor or feel for a thin spot. Broken strands of wire can produce intermittent concerns. Also check for harness damage caused by a past motor vehicle accident or broken motor mount. Either can cause concerns that aren't easily noticed. Inspect the motor mounts for newness and review the vehicle repair history at your dealership. It's also a good idea to run a 180-day OASIS warranty history to see if the vehicle's been repaired somewhere else. It's important that you protect circuit components from damage when you probe them. Avoid piercing the insulation on the wires or the weather-tight seal at the ends of a connector. Doing so invites trouble by creating a path for moisture and contamination to follow. The presence of water within a wire or connector will lead to corrosion and may bleed current through the moisture to nearby terminals, affecting other circuits. Also, don't force a probe into a terminal. You may damage the terminal or reduce its grip strength. It's a better idea to use a jumper wire that's been customized with the right size terminal when you're testing connectors. To check the continuity of a circuit that terminates at a connector, refer to a schematic of the connector and probe the feed and return terminals. When you have to make an electrical repair, it's best to use the tools and supplies available from Ford. They're engineered to make a tight connection that'll keep water and air out and ensure a stable, low-resistance joint. As I mentioned earlier, a wire harness terminal repair kit is now available from Ford. Included in the kit is a high-compression crimping tool, 6 each of 96 different terminals, and a variety of splice seals. The terminals are pre-crimped on 4-inch pigtails to simplify the repair. While the kit provides instructions, here are a few pointers. When splicing conductors, strip the insulation back 1/4 of an inch and pull straight out from the wire to avoid cutting off strands. If strands are cut, trim the end and strip it again. Using the crimping tool, place the desired terminal in the correct pocket. Then close the ratchet until the terminal is secure and won't fall out. Insert the stripped wire into the terminal end and depress the handles fully. Then inspect your work. There should be no insulation under the crimp, and all strands of wire should be inside it. To complete the job, insert the assembly into the splice until a positive stop is felt. Retaining fingers inside the splice will snap behind the shoulders of the terminal to lock it in place. To complete the drivability discussion we started a while ago, we have 3 topics to talk about. Here's the first. We learned of a number of 93 Rangers and Explorers equipped with 4-liter engines that stall on cold start after a soak of 6 to 8 hours. As a rule, the stall only happens on the first key up of the day and tends to occur more in warm climates than cold. Models with automatic transmissions tend to stall on drive or reverse engagement, while models with manual transmissions stall about 3 to 5 seconds after the cold start. These vehicles also may exhibit hesitation or stumbling on initial acceleration. The root cause of this concern is the relationship between the fuel that's being burned and the calibration of the vehicle. Seasonal variations in fuel mixtures are mandated by the government in its efforts at pollution control. Unfortunately, that means the customer is likely to continue experiencing the concern until the calibration is modified to compensate for seasonal fuel variations. To confirm that you're dealing with this condition, disconnect the vacuum hose from the fuel pressure regulator and plug the hose to prevent a vacuum leak. When you start the engine, it'll get a rich shot of fuel and should run normally. There won't be any trouble codes to help you because the oxygen sensor is still too cold to switch. In the short term, advise the customer to use the low-octane fuel specified for the engine or to try different brands of regular until he locates the one that works best. Going to a high-test fuel will only prolong the concern. Another drivability issue we've learned about is a surge at cruise in 90 to 92 Explorers and Rangers equipped with 4-liter engines, and in 87 and up Rangers and Bronco 2s equipped with 2.9-liter engines. This surge is a normal condition that's related to the computer program that controls fuel delivery. It's called the lean cruise strategy. At steady highway speeds, the EEC system stops the heated oxygen sensor from switching for fuel economy gains. The result may appear to be a mild surge. If you were to monitor this concern using a scan tool, you might think the heated oxygen sensors failed, though it hasn't. To verify that the system's operating in the lean cruise mode and prevent unnecessary replacement of the heated oxygen sensor, back off the throttle when you notice the sensor stop switching. Then tip into it again. You'll see the sensor resume switching, confirming that it's okay. As you know all too well, there are many possible causes of hesitation, rough idle, or stalling. If there's a TSB or OASIS message to help you out, that's great. But what if you work through the TSB and find the fault's still there? This is a risk that can be avoided by working through the diagnostic procedures in your manuals before turning to the TSBs. For the concern we're about to describe, the recommended diagnostic steps would, among other things, have you check the thermostat to see if it's sticking open or opening at too low a temperature. Either condition may result in hesitation and a rough idle, stalls during acceleration or deceleration, or unusual automatic transmission shifting sequences. Either condition also may set diagnostic trouble codes, providing valuable clues about the root cause. You may see a code 21 or 116, depending on the vehicle, indicating the ECT sensor value is out of range. Or you may see code 41, indicating the heated oxygen sensors not switching. This may trick the Powertrain control module into commanding extra fuel, resulting in an engine that runs rich and poor fuel economy. There's probably not a thing wrong with the sensors. They're just telling you that they've detected an irregularity. Of course, if you're dealing with a thermostat that's sticking open or opening too soon, a dead giveaway is when a customer complains of poor heater output. Fortunately, there's a TSB that addresses these issues. It's number 93144. It describes a new procedure and a device that can be used to check thermostat operation. Although this procedure applies to most Ford and Lincoln Mercury passenger cars and light trucks, both foreign and domestic, check the TSB to be sure it applies to the vehicle in your stall. If the engine fails to reach normal operating temperature, you see a low gauge reading, or heater or defroster performance are below par, check the coolant level in the radiator and recovery reservoir, being careful to avoid injury. If you suspect a coolant leak, pressure test the cooling system. If topping off the fluid or repairing a leak eliminates the concern, all well and good. If the level's okay and no leaks are detected, however, check the thermostat. The devices you'll use include the Rotunda Service Coolant Temperature Monitor Harness and a DVOM. With the coolant at the proper level and the key in the off position, disconnect the ECT sensor harness connector. Install the coolant monitor harness in the engine coolant temperature sensor circuit, matching the male and female ends as required. Because the coolant monitor harness is equipped with test leads that tee into the DVOM, it enables you to watch changes in ECT sensor output voltage as it reacts to changes in coolant temperature. For vehicles equipped with electric engine cooling fans, the fan must be running during this test on either high or low speed. To turn the fan on, either disconnect the air conditioning clutch power supply and turn the climate control to AC on, or disconnect the power supply to the fan and supply 12 volts to the fan from the battery. You may have to supply a ground for some applications. Set the parking brake and place the transmission in park for an automatic or neutral for a manual transmission. Then start the engine and allow it to idle throughout the test. Make your first ECT sensor voltage output reading after 2 minutes have passed. Make subsequent readings each additional minute. Be sure to write down the readings you observe. When the downward ECT sensor voltage trend changes direction or changes only slightly from the last reading, 0.03 of a volt or less, record this as the thermostat opening voltage. Then refer to the voltage and corresponding temperature chart on the TSB to relate the voltages you recorded to the actual coolant temperature in degrees Fahrenheit. If the opening point voltage is equivalent to a coolant temperature of less than 180 degrees Fahrenheit, or if it's less than 170 degrees Fahrenheit for the 2.3 liter HSC only, replace the thermostat. If the voltage reading indicates the thermostat's opening at the right temperature, return to the cooling system diagnosis chart and continue the diagnosis. When you make the final diagnosis and the required repair, whether you replace the thermostat or take another action, test drive the vehicle to confirm that the repair eliminates the concern. It's not enough to feel heat on your feet. You have to be sure the engine runs well too. And wasn't that a lot easier and less messy than changing a perfectly good thermostat? While most people tend to be pretty forgiving toward themselves if they spill a pint of oil when servicing their lawnmower, they'll be on your doorstep in a hurry if they think their vehicle's leaking. Leaks get noticed. Correctly identifying the source and putting a stop to a leak, whether you're dealing with engine oil, coolant, or transmission fluid, is a surefire way to please your customer. The first challenge you face in leak diagnosis is confirming that you're really dealing with a leak. What at first may seem to be a leak may be a normal characteristic of the powertrain you're servicing. As a rule of thumb, you're dealing with a leak when the customer notices fluid on the ground under the vehicle. You may not be dealing with a leak if you see engine discoloration or dampness. Here are some examples of misdiagnosed leaks that have resulted in the replacement of perfectly good parts. Water pumps are replaced more often than you might think for a normal condition that's mistaken for a leak. In fact, as many as 1/3 of all water pump warranty returns prove to be okay when we put them through a pressure and leak test. The water pump from a 2.3 liter engine shows what I'm talking about. Notice the discoloration here, around what's called the weep hole. Some people believe this is a sign of leakage or that the water pump's faulty. Not so. The weep hole is an important feature of water pumps. It permits a fine mist of coolant vapor to escape the cooling system during vehicle operation. As the vapor moves past the water pump seals, it has a lubricating and cooling effect that extends seal life. At normal operating temperatures, any vapor that passes through the weep hole evaporates. By the way, when you have to add engine coolant, be sure to note the location of the fill cap in relation to the rest of the engine. On some vehicles, especially those with sloping hood lines, the usual coolant fill opening is located below the high point of the cooling system. If coolant's topped off at the fill cap, an air pocket will still exist in the coolant crossover pipe. This may lead to poor heater performance, a drivability concern, and with a Mark 8, a low coolant message on the message center display. Refer to the service manual or to the under-hood label to determine the proper procedure for filling these engines. On the Mark 8, for example, you'll have to remove an engine cover to gain access to the crossover fill. Also be sure to follow a specific routine to properly remove all the air from the cooling system. We've recently learned of some conditions that have been mistaken for engine oil leaks, but are really just normal characteristics of everyday operation. The dampness around the cam cover gasket on a 4.6 is our first example. The cam cover gasket's made of a material that tends to absorb oil. After a while, the oil works its way through the gasket and appears as sweat along the outer edge. The dampness may become coated with road dust, making the condition appear serious, though it's not. There's nothing wrong with the gasket, and you could prove that to yourself by performing a leak test with a black light and fluorescent dye, or by pressurizing the engine and applying a soap solution. The key point to bear in mind is that replacing this or any gasket without first performing a leak test could be a false step. Here's an example of a condition that's relatively inexpensive to repair when it's properly diagnosed, but costly when it's not. Our engine this time happens to be a 5.8 liter. You'd be surprised to learn how often the rear crankshaft seal gets replaced when there's nothing wrong with it. Let me tell you, nobody does a better job of installing seals and gaskets than the engine plants. And to make sure they've done the job right, they test every engine before it's shipped. As we all know, an oil leak that appears to originate at the bottom or rear of the engine most likely originates someplace else. Gravity and wind tend to redirect leaking fluids down and then back toward the passenger compartment. In the case of the 5.8, for example, you're more likely to discover that what appears to be a rear seal leak is from another source. Until you clean the engine and perform a leak test, you can't really be sure you've located the leak point. You're probably familiar with this item, the transmission range or TR sensor. Until recently, it was called the manual lever position or MLP sensor. A number of TR sensors have been returned to us with the paperwork indicating they leaked transmission fluid here around the shaft. To tell the truth, that's impossible because there's no pathway fluid could follow through the sensor. What's been mistakenly called a transmission fluid leak at the TR sensor is actually a sweating of the dielectric material used to lubricate the sensor's mechanism. There's only one place a fluid leak can occur in this area, and that's through the shaft seal in the case. If that seal were leaking, the area should be cleaned and a black light and dye used to make absolutely sure. Back in the introduction, I said we'd be talking about Ford's exchange program. The exchange program provides a good alternative to making a repair when your diagnosis indicates you'll have to open the transmission case or perform a major repair on an engine. Although exchange programs were implemented to improve customer satisfaction, everyone wins. Customers win because they get a remanufactured transmission or engine that meets original equipment standards. The dealership wins because a confident customer is back on the road. The technician wins because he's had a timely completion of a major repair and is able to pursue more work. While exchange units are available for most engine and transmission families, factory rebuild exchanges are limited to engines or transmissions that are still within the base powertrain warranty period. If the powertrain warranty's elapsed, you'll have to make the repair or obtain a rebuild from a Ford-authorized remanufacturer. After you get a good write-up that thoroughly describes the concern and the conditions under which it occurs, start your diagnosis. If the diagnosis indicates that the concern can only be solved by repairing the unit out of the vehicle, consider your options. You could order the necessary parts and repair the unit, or, as a good alternative, you could get on the phone to the exchange program and get the wheels turning. The decision to rebuild or replace should be based on service to the customer, taking into account his time and money. In other words, what will get him back on the road in the most effective way. To contact the exchange program, call the 800 number of the distribution center that serves your dealership or handles the unit you need. These numbers are listed in the program book that accompanies this tape and in the exchange program information kept in your dealership. Before you dial, jot down the information you'll be asked when you call. At the minimum, you'll need the dealer name, address, phone number, and P&A code, the customer's name and phone number, the model year, vehicle line, and odometer reading, the VIN and date of sale, the repair order number, and a description of the customer concern or the reason for replacement. For an engine exchange, you'll need the engine code, calibration number, and engine build date. For a transmission exchange, you'll need the transmission serial number, model number, build date, and the assembly part number prefix and suffix. When the Ford representative picks up the phone, you'll be asked for the information we just listed. You'll also be asked a number of questions related to the diagnostic steps you took and your findings. For a transmission, the exchange program will want to know how the fluid looks and smells, if you found friction material or metal debris in the pan, if you heard a grinding or metallic noise when you engaged the unit, if the unit failed to engage in forward or reverse, if the transmission seized, if there's severe external damage or leakage, or if there's been a prior failure. For an engine, be ready for these questions. Is there engine knock? Have you completed an oil consumption test? Have you made a compression check or leak down test? Are any of the spark plugs fouled? And have you looked for oil leaks? It's also a good idea to jot down any diagnostic trouble codes you identified and have them handy when you call. Because the person taking your order is sitting at a computer terminal linked to one of Ford's mainframes, they have fingertip access to a record of prior exchanges for the vehicle. They may ask if you've performed the checks which are contained in the recent TSB or OASIS message before they process your order. If you've performed all the required checks, the rep will read you a control number that you should write down and keep in a safe place. You'll need it when the exchange unit arrives at the shop. The order next goes to a distribution center, usually by the end of the day, where it's filled and shipped. And in a matter of days, the exchange unit's delivered to your dealership. When you receive and unpack the unit, look for the plastic envelope. It contains important papers that you're responsible for, plus an instruction sheet. The instruction sheet tells you how to prepare the new unit to be installed and how to prepare the old unit to be shipped. It's imperative you read the instruction sheet before you do anything else. Also, fill out the return information card before you start the repair. You'll have to enter the control number you were given when you called in to place your order. Be sure to hang on to this card. You'll be attaching it to the unit you're replacing and shipping back. Remember, this is an exchange program, not a giveaway. You get a unit and Ford gets the old one. Failure to return the old unit in the shipping container will result in a costly charge to your dealership. Give the shipping label, the list of carriers, and the partially filled out bill of lading to the parts department. Parts must complete the bill of lading and call an approved carrier to make arrangements to ship the old unit to the address that appears on the shipping label. Now you can do your thing. Remove the defective unit and replace it with the exchange, being sure to note any precautions spelled out on the instruction sheet. When the job's done and the unit that's going back has been properly prepared for shipment and placed in the box, attach the return information card to it with the wire tie. Typically, it's parts' responsibility to complete the packaging and attach the label and bill of lading. Your job's done, and you've helped build customer confidence in you and your organization. You may want to take a look at your program book. We've included sample forms and additional information on important exchange program topics. When it comes to automatic transmissions, we have a number of things to talk about. By and large, the upgrades we'll show are designed to enhance the durability of the units. In other cases, upgrades provide improved shift performance. We'll start by discussing the E4OD, then move to the A4LD, then the AXODE. If you work on vehicles equipped with the E4OD automatic transmission or a vehicle modifier, you know it's a durable unit that has to work in a lot of harsh applications, everything from delivery trucks to ambulances to airport shuttles. That means heavy loads, lots of stop and go, and literally thousands of shifts a day. Since it was introduced in 1989, the E40D has undergone a number of upgrades to increase its durability and reliability. Exchange transmissions incorporate the latest upgrades. A convenient summary of the upgrades can be found in these TSBs. 921A is a reprint of all TSBs and OASIS messages for the E40D from the introduction of the unit in 1989 through April of 1991. 931220 extends durability upgrades to all vehicle lines covering the period from 1989 through March of 1992. I encourage you to locate and read these TSBs. They'll help you acquaint yourself with past and current efforts at hardening the unit. If you're a vehicle modifier, you should also read and strictly adhere to the instructions found in the QVM manuals and bodybuilders' layout books supplied by Ford. You see, a lot of warranty repairs result from incorrect modification procedures, particularly electrical. More about that later. Not covered in TSB 931220 are the upgrades we'll look at now. They too are designed to enhance the unit's durability. Chief among them are changes to the input shaft, the overdrive carrier, the output shaft, and the center support. Experience has shown that high-mileage vehicles used in heavy service applications may experience forward clutch failures due to wear at the junction of the overdrive center shaft and the output shaft here, where the center shaft's snout inserts into the center shaft bushing in the output shaft. As the bushing wears, the overdrive center shaft may tip, causing the forward clutch seal ring areas to wear. When the wear becomes too great for the seal rings to contain, forward clutch fluid leaks may occur and the forward clutch may fail. To alleviate this concern and a few others, a number of changes were required. We eliminated the center shaft snout and removed the center shaft bushing. In place of the bushing, we added a cup plug. This design delivers a controlled flow of lubrication out of the output shaft. We also changed the center support, adding a ball bearing to make up for the elimination of the center shaft snout and center shaft bushing. The support provided by the ball bearing assembly is more positive and less likely to suffer wear than the previous design. If you find yourself working on an E40D with a forward clutch failure, take a good look at the components to see if the concerns related to the condition we just described. A worn center shaft bushing and a tipped overdrive center shaft. If it is, you'll be happy to know a service kit's available. The service kit consists of a cup plug that's pressed into the output shaft after the bushing's removed, a new center shaft, and a new center support and ball bearing assembly. The center support will be stamped with a mark to indicate it's a service part, not a production version. Another E40D component failure is more common in high-mileage diesels. It's this cracking of the overdrive carrier. To attack this concern, we removed the pilot, shortened the input shaft by 12 millimeters, and according to tests we've run, these changes improve metal fatigue life by as much as 200%, and that should eliminate the cracking concern. Although you can use either the longer or shorter production version of the input shaft with the service kit, only the shorter shaft and carrier will be available as service parts. Never substitute the new short input shaft for the earlier longer version unless you also replace the overdrive carrier. Doing so may damage converter or input shaft splines. A4LD, the automatic 4-speed lockup drive transmission, has seen some changes too. They affect how you work on the unit. For 4-liter applications only, from a build date of November 3, 1992 to the present, a clipped-together forward gear train assembly is being used. It's a change from the non-clipped-together model that was used with the 4-liter prior to November 3, 1992. One of the key techniques to working with the new design is learning how to take it apart and put it back together without doing any damage to it or the internal components. All that's needed for the disassembly is a flat-bladed screwdriver. Place the clip-together forward gear train assembly on a solid work surface and locate the two locking tabs. They're 180 degrees apart. Insert the tip of the screwdriver over a locking tab and into the locking groove. Then press down until the tab is released, using the top of the tab as fulcrum. It takes very little pressure. Repeat this procedure to unlock the opposite locking tab. Be careful not to bend the tab too far outward or the input drum will become permanently deformed. A damaged locking tab can lead to a failure of the input drum and direct clutch, resulting in no third gear or reverse. To lock the unit, use a soft-faced hammer. Place the input shell over the direct clutch and strike the shell one time at one locking tab, one time at the opposite tab. Then repeat the blow to the first to center the locking tabs in the locking groove. That's all there is to it. Never attempt to join the halves by striking the overdrive sun gear. The locking tabs and groove won't seat properly. Also, striking the overdrive sun gear may cause it to shatter or the force of the blow may be transmitted to and damage the forward carrier bearing. The change to the 4-liter clip-together assembly required some additional changes to the A4LD. For example, the clip-together 4-liter application requires a thicker and wider center support seal. The redesigned load path of the 4-liter clip-together model also resulted in the replacement of the number 3 and number 5 thrust washers with thrust bearings. The number 4 thrust washer was eliminated altogether in the clip-together design. To select the correct size number 5 thrust bearing, place a gauge bar on the case shoulder and set a depth micrometer on top of the gauge bar. Extend the probe until it contacts the number 5 thrust bearing surface at the forward clutch hub surface. Remove the micrometer and record this reading as dimension A. Now move the micrometer to the opposite side of the gauge bar, repeat the measurement, and record this reading as dimension B. Add dimensions A and B together, divide by 2, then subtract the thickness of the gauge bar. This gives you dimension C. Locate the correct number 5 selective thrust bearing from the chart in your shop manual. When you're servicing an A4LD, be sure to pay attention to your service manual. The procedure we've just shown applies only to vehicles that are equipped with 4-liter engines that have a transmission build date of November 3rd, 1992 and later. A4LDs in vehicles with 2.3 and 3-liter engines don't have a clip-together forward gear train assembly, so they're serviced as before. There are a couple of things about the AXODE we have to cover. The first is a new filter and retaining clip that are in production now and will be available as service parts in the near future. The most striking feature of the new filter is its size. Although it's noticeably smaller than the earlier model, it'll retrofit to previous units. An important feature is the dam that's stamped in the bottom. When the filter's installed, the dam rests on the bottom of the oil pan, where it helps control fluid entry at the intake. When you replace an earlier filter with a new design, also install the new design retaining clip. While the earlier clip supported both the filter and the tube, the new clip supports only the tube. The other AXODE topic is service-related. Specifically, some customers have noted a wobble of the speedo needle. To resolve this concern, first determine if the vehicle you're servicing is equipped with a speedometer cable. If it is, check the cable for kinks and straighten it out as much as possible. While this video is not intended to provide an in-depth discussion of powertrain diagnosis, there are some points that can't be overlooked. This is especially true when you're servicing an electronic transmission. We've found that the handiest tool you can use is this flow chart. If you do what it says, you'll get to the root of any transmission concern. The thing I want to draw your attention to is up here at the top. This box lists the basic checks that must be performed, plus quick tests and recording of diagnostic trouble codes found. These checks will help you better understand what you're dealing with, and they may save you some time. When we discussed the E4OD, I said that a lot of the warranty we've seen is due to improper vehicle modification, particularly electrical. It happens when non-factory items like brake retarders or idle kickers are installed and wired into the wrong circuits. Always check closely for non-factory add-ons when you're diagnosing a transmission or transaxle concern. If they're not installed correctly, they may blind or confuse the powertrain control module and cause erratic shifts or reduced shift quality. Never wire any add-on device into any part of the EEC system, and that includes sensors and actuators. Do only as the vehicle modifier manuals recommend. If you've been reading your TSBs lately, you may have noticed that number 931221 discusses a new cartridge-type hub oil seal. It's being tested on 5,000 1993 F-250 and F-350 light trucks as a potential solution for a leakage concern that's associated with the original equipment hub seals. Here's what that TSB was talking about. The 10¼ axle wheel seal is one part of a new service kit that also contains an oil slinger, an inner cone and roller assembly, and an instruction sheet. Effective in the spring of 1994, this kit will be available as a service part to retrofit leaking rear wheel seals on F-250 and 350 vehicles equipped with Ford design 10¼ ring gear full floating rear axles. These components will go into regular vehicle production in the spring of 1994. The new seal is equipped with premium Viton rubber at potential leakage points, the inner and outer diameters, and at the lip. Viton rubber has excellent wear characteristics and temperature-resistant properties. The oil slinger is a new feature. When installed, it acts like a dam, reducing the pumping action of lubricant through the inner bearing. The slinger also helps position the seal sleeve squarely on the spindle, reduces heat generation within the seal, and reduces wear on the housing spindle. The inner cone and roller assembly is shorter than its predecessor by 32 thousandths of an inch. This shorter dimension allows for the thickness of the slinger. To replace a leaking seal with the new kit components, you'll need these service tools. Hub seal replacer, number T93T1175AR. Hub nut wrench, number T85T4252AH. Step plate adapter, number D80L6307. Puller tool, number D80L1002L. Torque wrench, and a bearing packing tool. You'll also find a list of these tools and their part numbers in the program booklet. To begin the procedure, set the parking brake and loosen the axle shaft retaining bolts. Release the parking brake and then remove the brake drum. If push-on sheet metal drum retainer nuts are present, remove and discard them. Push-on nuts are installed in the factory for shipping purposes but have no effect on vehicle function. Next, remove the axle shaft bolts and pull out the axle shaft. When removing the hub nut, never use power impact tools. Instead, use the recommended hub nut wrench and engage its drive tangs in the 4 slots in the nut. If the nut comes apart during removal, discard it. As the hub nut's removed, it'll ratchet. Be sure to loosen the nut in a counterclockwise direction for right-hand thread and clockwise for left-hand thread. With the hub nut removed, install the step plate adapter and then the puller tool. Loosen the hub to a point where it can be removed by hand. As you remove the hub, hold the outer cone and roller in place so it isn't accidentally dropped and damaged. A small number of 1991 F-250 and F-350 vehicles with full floating rear axles and single rear wheels were built with a dust deflector which is snapped into a groove inboard on the axle housing spindle. If it happens to be present, carefully remove and discard the plastic deflector by positioning a pry bar at the rear of the deflector. The deflector must be removed and discarded before the hub assembly with new parts from the kit can be installed. To remove the seal from the hub assembly, use a thin-bladed and larger screwdriver. Being careful not to scratch or gouge any of the sealing or bearing surfaces, use the thin-bladed screwdriver to pry the seal up from the bottom of the bore. Use the larger screwdriver to complete the removal. Because the existing seal will be discarded once it's removed, don't be concerned if its outer retaining ring becomes dislodged. Just continue the process and remove the inner seal sleeve and seal. A new seal must be installed each time the hub assembly is removed. When all seal parts have been removed, discard them unless they must be held for warranty review. If this is the first time the seal's been serviced, you'll use all of the components in the service kit. If the unit's been serviced before using the new kit, replace only the seal and leave the oil slinger and the inner cone and roller assembly in place. Note that the new seal is available as a separately serviced item. To continue, remove and discard the hub inner cone and roller assembly. You'll recall that the replacement is shorter to allow for the thickness of the oil slinger. Thoroughly clean and inspect the hub seal bore. Remove all sharp edges, nicks, and burrs to prevent cutting the new seal during installation. Pack the new bearing cone and roller assembly with a bearing packing tool using premium long life grease. Pack the hub outer cone and roller using the same method. Place the new hub inner bearing from the kit in the cup. And then lightly coat the seal bore with clean motor oil. Don't coat the seal bore with grease. Position the oil slinger on the bearing cone with the tabs pointing toward the bearing. Then, after making sure the hub seal is free of dirt or grease, install the hub seal from the kit on the hub seal replacer and apply a light coat of clean motor oil on the outer diameter. Position the installer tool and seal on the hub, making sure the seal isn't cocked, and insert the tool and seal squarely into the hub. With the hub sitting on a solid surface, strike the handle until the seal is fully seated. If the hub seal is cocked during or after installation, remove and discard it and install a new one. After you install the seal, wipe the seal and hub area as shown, and inspect the seal inner diameter to make sure it's clean and that the seal is installed squarely. Apply a light coating of clean motor oil to the seal's inner diameter before installing the hub assembly on the spindle. To prepare the spindle for reassembly, inspect the sealing surface for scratches or damage. Also inspect the inner shoulder for damage from the turning of the bearing cone you removed. Remove all scratches, gouges, or galling with number 600 or finer wet or dry sandpaper, then wipe clean. With the spindle clean, lightly coat it with clean motor oil or axle lube. Then fill the hub cavity with clean motor oil. Holding the hub outer bearing in place to serve as a pilot, push the rear hub and hub outer bearing onto the spindle. With the hub in place, install the hub nut. If it comes apart during installation, replace it with a new one. To start the hub nut on the spindle, engage the tab in the keyway prior to thread engagement, then turn the nut clockwise for right-hand thread or counterclockwise for left-hand thread. To complete the tightening of the hub nut, install the lock nut wrench on the spindle, and using a 100 foot-pound torque wrench, tighten the nut to 75 to 88 Newton meters or 55 to 65 pounds-feet. When the specified torque is reached, ratchet back 8 teeth or notches on the hub nut, the equivalent of 1/6 of a turn. You must hear 8 clicks during this operation to perform it correctly. Before installing the axle shaft, inspect its O-ring seal for cracks, nicks, or wear, and replace the seal if any are present. When you're satisfied that the O-ring seal is okay, install the axle shaft. Clean and dry the 8 axle shaft retaining bolts before installing them, and apply enough blue thread lock and sealer to fill all voids in the area of thread engagement. Only a few drops are needed. Install and tighten the bolts just enough to seat them. Don't attempt to torque these bolts until the tires are once again on the floor. Install the brake drum and install the wheel and tire. With the vehicle still in the air, loosen the filler plug. If axle lube seeps out, the level's okay, so tighten it. If the axle lube doesn't seep out, remove the plug and fill to the bottom of the filler plug hole with the specified lubricant. Wipe any particles off the magnetic fill plug and install and tighten it to 21 to 40 Newton meters or 15 to 30 pounds-feet. Lower the vehicle. Tighten the lug nuts to 190 Newton meters or 140 pounds-feet. And torque the 8 axle shaft retaining bolts to 82 to 108 Newton meters or 60 to 80 pounds-feet. Make whatever brake adjustments are required. Here's some advice on a procedure a lot of people take for granted, especially some of those quick lube shops. Just like in the old days, they routinely top off the fluid till it runs out the filler hole. Depending on the application, that may be a mistake that can lead to a seal repair. Overfilling can cause axle and pinion seal failures. The turbulence and heat that are generated in the axle can create enough expansion of the fluid to force lube out the vent tube. To prevent unnecessary damage like this, be sure you know what the correct level is by checking the specifications printed in the service manual and in the program manual that comes with this tape. For axles manufactured by Ford, we recommend that you don't check the lubricant level unless there's a definite leak or you've serviced the axle. If you have to add lubricant, like we did to complete the repair we just showed, be sure you know what the correct level is. Fill levels vary from one application to another. While some models are filled flush with the bottom of the filler hole, others are filled to a specified level below the filler hole. If you discover the correct levels below the filler hole, take a length of rod, welding rod works good, and make an L-shaped bend to create a dipstick. If you want, you can scribe the rod at the prescribed fill level. Holding the long end of the rod parallel to the ground, insert the L in the filler hole, making sure it's at 90 degrees to the ground to get a good reading. Then remove the rod and measure the level. If you have to add lube, add only enough to reach the recommended level. Although most axle lubricants have changed very little over the years, you'll probably be seeing new lube specifications in the near future for certain applications. Keep your eyes open. More than ever before, servicing a vehicle requires that you understand how powertrain components interact. While engines and transmissions still rely on the same types of mechanical components they always used, the network of sensors, control modules, and actuators determine how those components respond to driver demands and how the customer perceives vehicle performance. This new world of vehicle control places additional demands on your diagnostic and repair skills. While an educated hunch is a sign of a skilled technician, it's often not enough. That's why we ask you to bear with us when we keep saying, go to the service manuals. We've demonstrated that they work. For additional information, take a look at the program and quick reference booklets that came with this tape. We're sure you'll find them handy.